So good day. Today we are going to see the new update for the DoublyLinkedList exercise. So from the previous video, you see I've already created a scanner object, instance variable such as head, tail, int length, and then a class node that consists of properties such as data, next, previous, a constructor for it that has a parameter of data and then returns data. Then a constructor for double linked list class, and also I've created a public boolean which name is empty that returns true or false if the double linked list is empty or not, and then a public int length that returns the length that will be incrementing if there is a new node added to the double linked list. So first, the value adding to the first node. So this is the function that we've created from the previous video, adding value to the last node, displaying the first node, calling the last node, and then displaying all the items on the doubly linked list in a forward direction, and this is for the backward direction. The new added operation on our double linked list program. So the first one that we've created is public void insert after the target node, and it has two parameters, which is the data or the value of the node that we are going to insert, and then the position or the target that we are going to insert our data. And then I've created a node object temp, it's equals to head, and then the object new n is equals to new node data, and we are going to check the position. So while temp.data or the head.data is not equals to the position that the user wants, and the temp or the head is not equals to null, then we will proceed to this operation. Temp is equals to temp.next, and after the looping of while loop, we'll proceed to the if condition. If temp.data is equals to tail.data, which means if the data is equals to the tail node, it will automatically add to the last node because it was the tail. And then else, it will start from the head. So node, we are going to create a node object q, will be pointing to temp.next, and the temp.next will be pointing to the new node object that we've created from here. This is the new n object from our node, and then new n dot previous will be pointing to the temp, and new n dot next is equals or will be pointing to the node q, and after that q dot previous will be pointing to the new node n. And then deleting the first node to the linked list, so it is easy. If we are going to check if it is empty. If the double linked list is empty, then it will return empty. Else it will proceed to this operation. Head is equals to head.next, which means the head will be pointed to the next, and the head that previous will be equals to null, or the previous head will be null, so it will be removed. Same from the delete last node, it will be reversed. So first we are going to check if it is empty. So the second operation that we created are delete the specific node value input. So public void delete specific node. It has a parameter of int data, and then we've created node pointer, node name pointer object equals to head, and then as usual it will check if it is if the double linked list is empty, then it will return empty, and check if the data is equals to the head data the user inputted is equals to the head data. If it is, then it will proceed to the delete first node function that we've created last time. Then else if the data or the value that we inputted is equals to the tail data, then it will proceed to the delete last node function, and then else it will make its own operation while pointer.data is not equals to data and pointer is not equals to null. Then same as the other one, it will keep doing this operation. Pointer is equals to pointer.next, so the pointer or the head is equals to head.next, so it will keep pointing to the head.next until the condition on the while loop is equals to pointer.data is equals to data and pointer is equals to null, then it will stop. And then so we've created an object named prib is equals to pointer.previous, and then node object n is equals to pointer.next. So prib name point node dot next is equals to n, and then n dot previous is equals to prib. So and after that it will prompt a success that node was deleted. And then for searching location item the linked list, it's just simple. So public void search item, so same as it has a parameter data, and then node object name temp is equals to head, and then create a counter variable and initialize it to 0. It will be our counter for how many nodes are there, and then it will check if the double linked list is empty, and if it is empty, then it will return empty. Else, while temp is not equals to null or head is not equals to null, then counter will be incremented, and then we are going to check if temp.data is equals to the data that the user is inputted, and then if it is equals to the data, then it will prompt the item as found, and we are going to print the counter variable. And then temp is equals to temp.next, which means if it hasn't find the temp.data is equal to data, then it will proceed to that temp is equals to temp.next, which means it will be pointing to the next node, and it will continue looping until it's done. So good day, this will be the execution of the program Doubly linked list. So the program will be menu based and composed of 11 operations. So let's start. For number 1, let's add a value for the first node. So let's try to. And then let's add another one for the first node. That's 3, 4, and 5. So our doubly linked list composed of 5, 4, 3, and 2. And then choose 2. Enter a value for last node. So we're going to insert another node, but in the tail node, in the pointing at the tail of the doubly linked list. So enter a value of 10. So 10 was added at the last node. Then 3 will be displaying the first node. It displays 5, and 4 it display the last node. Then 5 will be printing out the doubly linked list in forward direction. So 5, 4, 3, 2, and 10. 5, 4, 3, and 2, and 10. And then 6 will be reversing the display pattern. So it will display 10, 2, 3, 4, and 5. So let's see. So 10, 2, 3, 4, and 5. It's just a reverse for just the reverse of forward. And then 7, insert after selected node. So enter the value that we would like to insert. So for example, I would like to insert 20, and then I would like to insert it after 2, the node 2. So 2. So as you can see, 5, 4, 3, 2. Then after 2, 20 was added, and then continues to 10. And then 8 will be deleting the first node. So the first node was deleted, 5. Then the last node is 10. So let's try to delete it by using the 9 choice, which is deleting the last node. So the remaining item on the doubly linked list was 4, 3, 2, and 20, because 10 was deleted. Then let's try 10, which is deleting a node in a specific node that we choose. So let's try the value that the node that we want to delete. So for example, I would like to delete node 20. So let's try. Then the output is 4, 3, and 2. The 20 was deleted, or the fourth node was deleted. Then let's try 11, which is searching an item or a node and display its location. It was it this is a one based. It is starting from 1 until the rest. So let's try 11. Then I would like to search for number 2, which is 2 was the last node. So if we are going to count 1, 2, and 3, so position the last node 2 was on position 3. So let's try if it is correct. Enter the value. I want to search 2, and then enter. Yeah, that item has found on node 3. Then 0 for quitting the program. So bye, thanks for using the program. That's all.